Using the Solid Edge startup screen, we're going to open an existing assembly. There are many options geared towards handling massive assemblies, like hiding all components for super fast opens or opening a specific design area with a zone or configuration. This assembly already contains the 2D layout that we previously opened from AutoCAD in an assembly sketch. We've also added a lot of virtual components. These components are placeholders for future parts and assemblies and enable us to quickly build an entire assembly structure without initially creating documents on disk. So let's take a look at how this works. If you're working on a familiar design, more often than not you'll have a good idea of what it needs to go into this assembly, so why not capture this up front? That's what virtual components is all about, a tool for jotting down your ideas quickly. We can enter our own part name or choose one from the library of components. Watch as we add more sub-assemblies. If the structure is not the way we want it to look, we can simply drag and drop components to arrange the assembly tree exactly the way we want it to appear in production. This tree really represents our bill of materials. Working with virtual components is ideal during the initial or conceptual phase of any assembly design. We can add as many components as we need, and remember that these will at some point become real parts. The key here is to be able to organize our structure however we want. We can also add real parts and sub-assemblies to our design. While you may expect to see physical 3D components when we're done, Solid Edge has some built-in optimization that we'll take a look at a little bit later. Now the assembly tree lists the new and virtual components, and they are in the right spot. Keep in mind at this point, no additional files have been created. We'll do this later. Think about the power here. We have no files to manage and performance will be optimal. This is just the thing we need to work with massive assemblies. And now that both the structure and the layout are complete, the next natural step is to tie the 2D sketch components to the virtual components. We call this unique workflow 0D. We'll take a look at this entire process by drawing some elements, adding some dimensions, and then assigning the geometry to a virtual component. If we remember the easy-to-use drawing tools we used back in 2D, these same commands are available in 3D. So for instance, we have the layer control, and we also have access to the lines, arcs, and so forth in the sketching tools. So we can quickly add a couple of smart dimensions here to precisely locate the profile relative to the plant walls, and also precisely size the frame for our boiler room. As I said, this component is actually going to be a subassembly of the boiler. So with our 0D workflow, we can easily assign the rectangular sketch to the boiler frame subassembly. All we need to do is right-click on the boiler frame component, select Edit Definition, and then fence select the geometry. The final thing then is to determine the origin for the block or the virtual component, and also the x-axis. Next, we're going to create some more geometry to represent other components inside of this boiler frame. The internal components can be assigned to the other virtual components in the boiler subassembly in the same way that we assign the frame to the sketch. Assemblies typically contain common parts, and we'll call these instances. And fast duplication of virtual components only require that we determine their position in the assembly. Think about the power here. One simple rectangle and its node in the tree quickly becomes several parts. The bill of materials will automatically sum the counts for us. Some immediate advantages of this process allow us to show and hide complete sketches by setting the visibility in the virtual component, a familiar process found with the actual 3D parts. Just like when we brought in blocks, you can use the A and the S to rotate the virtual components as you place them. Again, we're going to edit the definition to assign this to the next block in the boiler frame. The final thing we're going to do is draw a circle to represent the pump, the vertical pump. I'm sorry, the vertical tank, excuse me. We're going to click on the center for its origin and then click the silhouette point for the x-axis. And once again, all we need to do is position the second vertical tank. You can easily see the power of taking 2D layout and assigning it to the virtual components in the tree. The similar process also works with the existing 3D data. Remember that when we created the assembly tree using virtual components, we added 2 real components. Those are now listed in the assembly tree, and we just need to tell Solid Edge where they go. We're going to edit the profile of the upper level sketch, which is where we want to place the real components. A simple drag and drop will place the conveyor turntable into the assembly, and again, using the model key points, the correct fit and position are guaranteed. Let's see this process again with another virtual but real component. Later in the process, when we are ready to commit to this project, we'll publish the virtual components where all the nodes will become actual files on disk, and the 2D sketches will also come to life with the actual 3D models. It's really quite impressive. Our 0D workflow enables us to mix and match data types so we can maximize reuse and take full advantage of existing 2D layouts. So far we've used virtual components based on 2D sketch elements. We've added virtual real components with 3D components, but in a simple 2D form. So now we're going to complete the story with a 3D model. Notice that when we're in the sketching environment, we can still place this 3D component and position them to the layout. The capability allows us to properly position the 3D components from the 2D perspective, and it's done in this one simple environment. We can choose to move the 3D assembly to the sketch or vice versa, and in this case we're going to make the sketch drive the position of the 3D component. Simply snap an endpoint on the 3D component to the 2D sketch. And as we create one more connection point, it will rotate the platform into the proper position. So positioning the parts in this manner gives us the ultimate position control given a 2D view. We could position this assembly relative to the front view, but as this is just a plan view layout, we can quickly just set this machine directly on the shop floor by creating another alignment relationship. Think of 0D workflow as a digital sketchpad. We simply sketch and outline and position of the major components, and at any time we can modify their location and add or remove content at will. When we're sure the design is ready for the engineering team to complete, we simply need to save the virtual components to actual files. This last step is where we publish the design. Because of the fluid approach to assembly development, we didn't need to worry about where the data was. But now we're going to create physical files. So let's set the path to our project folder so the newly created documents will be placed there. And the actual 3D parts that we added will remain in the respective folders. For example, our parts libraries will still contain all of our common data. Also notice the intelligence of the system by using simplified representations. Large assemblies such as plants and equipment consume resources, and this option will help us retain as much computing power as possible. So let's take a look at what happened after publishing. Notice the assembly tree lists the physical documents in the exact structure as our virtual assembly. A more obvious change is what happened to the layout. Notice that the layout is still there, but the virtual components have been replaced by their actual 3D counterparts. It's easy to see how the performance gains that we'll get with 0D. Users can build massive assemblies entered on a 2D layout and have an accurate representation of the shop floor during planning. Only when the design is ready for details do you need the 3D.